A few quick examples of finding side lengths using trigonometry. So I have to always remember SOHCAHTOA. SOHCAHTOA. So when I look at this first triangle, the 39 degrees up at the top, I see that X is next to the 39, it's the adjacent, and 164 is the hypotenuse. So I'm adjacent and hypotenuse, which means I'm using cosine. So I say the cosine of my angle, 39 degrees, is equal to the adjacent x over the hypotenuse, 164. So that cosine of 39 is a decimal. I'm going to put it over 1, and I'm going to cross multiply. X times 1 is x. So x equals, and cross multiply, 164 cosine of 39 degrees. So on my calculator, 164 times the cosine of 39 degrees is to the 10th 127.5. So x would be 127.5. Next one with a 40-degree angle. 86 is the opposite. X is the hypotenuse. Opposite and hypotenuse, that would be sine. So it's the sine of 40 degrees equals the opposite of 86 over the hypotenuse, which is x. Again, I'll put the sine 40 over 1 and cross multiply. 86 times 1 equals x times the sine of 40. To get x by itself, I have to get rid of that multiplication, which means I'll divide. So I'll divide both sides by the sine of 40. So x then will be 86 divided by the sine of 40. And that into the nearest tenth is 133.8. Last example, with a 48 degrees, I see that 118 is the opposite. X is the adjacent. Opposite and adjacent, that's tangent. So the tangent of 48 degrees is equal to the opposite, 118, over the adjacent, x. Again, I'll put the tangent of 48 over 1 and cross multiply. 118 times 1 is 118. X times the tangent of 48. To get x by itself, I divide, just like the last one, the tangent of 48. So x would be 118 divided by the tangent of 48 to the nearest tenth. X ends up being 106.2.